Let's look at this first one. Solve for the variable x plus 1 quantity squared. I don't know. Step 1. Write it in standard form and solve the related equation. Oh, that's too much. You go there. Write in standard form and solve the related equation. Standard form says everything on one side, 0 on the other. Do we have standard form? Yep, check. So solve the related equation says ignore your inequality for this step only. Put an equal to sign there. What would you get for x? Negative 1 and 4. Right. If you're going to go about the algebraic way, you absolutely need a number line. So step 2, draw a number line and divide it into sections using the numbers from step 1. Now, it's a good idea to use a different color, use a different symbol, because we're about to mark up this graph, this number line, I should say. Thanks for agreeing with me. So notice I'm using tick marks for our negative 1 and our 4. Later on in calc, they're going to throw out a phrase like critical numbers. It's not the best wording for us right now, but we need to make a distinction somehow between the numbers we got in step 1 and what we're going to use in steps 3 and 4. So by drawing this number line, we have created 3 sections. This section to the left is all numbers less than negative 1. This section is the numbers between negative 1 and 4. And this section are the numbers greater than 4. So step 3, from each section, pick a test number. And determine its sign. From each section, pick a test number and determine its sign. So we got 3 sections. Give me a number that is less than negative 1. Negative 2. Give me a number that is between negative 1 and 4. Sure. Give me a number that's bigger than 4. 6 it is. Notice I used a different color and I used a different symbol on the number line. I used dots instead of tick marks. What you're going to do is you're going to plug in your 3 test numbers into the left-hand side of your inequality. So we were already in standard form. You want to look at the standard form version. Comment. Strongly encourage you to use your calculator. You know, I'll just do this. It'll be so much easier. If you go into y equals and you type in your function, I mean, you got to use them while you have it. While you have it. While you have it. While you have it. With your calculator. 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 Go back to second table set. Make sure that independent is on ask. Dependent is on auto. So now, if you go to second table, you may have some numbers there like I do. Just hit delete to clear them out. And now we're just going to type in -2, enter, 2, enter, 6, enter. The reason we have those is because those are test numbers. We don't care about the numbers, we only care about the sign. So by plugging in -2, notice we got y to be negative, which means any number that you picked to the left of -1 will always be negative. That's what it means to be a test number. Any number you pick between -1 and 4, like 2, will always be negative as well. Any number you pick after 4 will always be positive. So as far as our sign chart is concerned, we would say negative, negative, positive. As we just saw, the signs did not alternate. Do not do 1 and then alternate from there, because, nope. How should we have known the signs were not going to alternate around -1? What's the multiplicity corresponding to -1? 2, which means the graph does what to the x-axis there? Touches, and when it touches, that means the y's do not change sign. That tells you why we should have expected the same sign around -1. Sure. Now that we have our signs, these test numbers, -1, +2, and 6, do not matter anymore. They are not part of the answer. Only our critical numbers, if you will, from the first step are important. So step 4, the solution includes all sections whose sign agrees with the inequality. If non-strict, meaning it's got an equal to, include the values from step 1. All right, so again, these signs correspond to the functional values. So we don't care about the x values being positive or negative. We care about the corresponding functional values being, in this case, less than 0. So less than 0 means what? Positives or negatives? Negatives. So notice we have 2 negative sections. Bright green. We got this one here. Oh, that's bright. And we have this one here. We'll go purple. That's fine. They are adjacent to one another. But why can't I say -infinity to +4? Why? There's no equal to here. So we have to keep them separate. You would say -infinity to -1, parentheses, That's that first section. Union, start it back up at -1 up to 4. Parentheses. Since we have something that's strict, we can't include the numbers from step 1. So as long as you pick a number that's less than -1 or between -1 and 4, not including, you'll find the solution to the inequality. So that's the algebraic approach to it. The graphical approach is a little more theoretic. You still have to do step 1. We have -1. We have 4. Where will my arrowheads be? What quadrants? First and third. Yeah, you said it fine. And according to multiplicity, you would touch and then cross. Well, notice for these x values here, I picked the wrong color. The graph is below the x-axis. That's what this would say in English. Where's the graph below the x-axis? And then looking at the graph, that'd be to the left of -1 or between -1 and 4, which is the same answer. So if you want to approach it algebraically, which is all 4 of these steps, totally fine. If you want to do step 1 and draw a picture and get your answer that way, totally fine. However, the rational version will not be fine for a graph. It's too involved because you have all your asymptotes and holes and whatnot.